What's up guys, welcome back to the channel. In this video tutorial we are starting the tree data structure series. So this is the first video of our tree data structure series in which we are covering all the concepts regarding the tree data structure and also solving some problems which might be asked in the interview in a product based company. So let's get started with the tree data structure. This is the first video of our tree data structure series. So make sure you have subscribed our channel and also press the bell icon. So first of all, let's talk about what is the tree data structure. So whenever we talk about the tree data structures in the computer field, it might comes in our mind like it is related to the original real world tree like this one. If I take this example, you have seen the tree like this in the real world. So let me explain you. It is quite similar. It is something similar to the our tree data structure is something similar to this tree in a real world. So let's explain what is the tree data structure is. So basically a tree data structure is a non-linear data structure. Clear? So non-linear, first of all let me write here, it is a non-linear data structure. Non-linear data structure, first of all it is. Clear? So tree is a non-linear data structure. The second thing is basically it is a non-linear data structure. I hope you understand this concept. What the second thing basically, it is a hierarchical data structure. So what is the meaning of this line? This is a non-linear data structure. You might have learned about the arrays, linked lists. As you know that in the arrays or a linked list, the data values of data items are stored in a sequential order, one after one. So in the case of a tree data structure, it is a non-linear data structure, means in this there is a parent-child relationship between any two values. Clear? So this is, I will show with the example also. So this is a non-linear data structure. Second thing, it is a hierarchical data structure. Clear? It is a hierarchical data structure. So this is clear. So it is also a hierarchical data structure. So hierarchical means, as we know that in our colleges or in any department there are different types of the departments. In any institute there are different types of a department. These departments are linked with each other. So basically that type of information when stored, it should be stored in a hierarchical order, that this particular department belongs to this particular field and so on. For example, let me show you an example of a hierarchical data structure, that is a tree. So let us suppose I am making a tree here. So in this series, whenever we are talking about a tree, so I am taking basically a binary tree, because basically binary tree is, most of the questions are related to the binary tree, and then we will discuss after some videos binary search tree. So whenever I am talking about a tree, means I am talking about a binary tree. So binary means 2. So in this case we having at most 2 nodes. So let me represent first of all. So let's take an example of a tree. So suppose, first of all, one more thing is it is a node based data structure. Node based means in this also there are nodes which are linked with each other in case of a linked lists. So it is a node based data structure. You need to note this point also. Clear? So it is a node based data structure. So this is a node based data structure. So let us take an example of a tree. Suppose this is a node, and with this node I have connected this node, with this node I have connected this node. Clear? So with this node I have connected another node, and similarly here is the node, and let's suppose I am also connecting a node here, as well as I am also connecting a node here. So this is a tree data structure representation. In this way we represent, graphically we represent a tree data structure like this. So let's take a, so all of these are nodes. This is a node, 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 this is also a node, the yellowish part is a node, and this is also a node. So basically if you carefully observe, it is representing a hierarchy. If I take it as any department, it as a department. So this department having a two more sub departments, this one, and similarly this department also having a two more sub departments, this department and this department, and so on. In this way, basically the tree data structure is represented. And what about the nodes? A node, basically a unit, we can say smallest unit in a tree data structure, which can store data information. Okay, so which can store the data as well as the link to the another node. So here any type of data can be present. Let's take it as a integer data. So if here is a 2, maybe here is a 1, here is a maybe 2, here maybe a 3, here maybe a 4, here maybe a 5, 6 here, and 7 here. So any type of information or data can be stored in these nodes. So I hope you are understanding what is the tree data structure is. So let us talk about some terminologies before directly implementing a tree data structures and going to the coding part. In this video I am only discussing the basic and the introduction to the trees. So this is how our tree data structure look like. So let us now talk about some terminologies. So first, the terminology is a root node. So basically if you relate it with the real world tree, if you carefully observe, the topmost node is known as a root node. So clear, this is a root node. Clear. So this node is a root node. So basically the node on the topmost of the tree, which is present on the top of the tree, is known as a root node. So this root node is basically related to the original tree root, which is in the bottom. So if we invert that tree, basically the topmost node is known as a root node, which is on the top of the tree. Clear. And all other nodes are basically, these nodes are the children of this root node. Clear. So this is the concept of a root node. I hope you understand what is a root node. A root node is basically the topmost node in a tree, which is on the topmost level. Clear. So I hope you understand what is the root node is. So let's move to the next part. So let us understand what is a parent-child relationship basically is. So let us suppose if this is a parent node, let us suppose this is a parent node. If this node is a parent node, then this will be the children of this parent, this will also be the children of this parent. So for this parent node, what are its children? 4 is its children as well as 5 is its children. Similarly for this particular parent node, if it is a parent node, if I consider it as a parent node, if it is a parent, clear, if it is as a parent, so what will be the children of this? This will be a children of this node, and this is also will be a children of this node. So basically this is representing a parent-child relationship. Clear. So this is basically the concept of the parent-child relationship in a tree. So I hope you understand this one. So let's move to the next part. Clear. So now let's talk about the leaf nodes. What are the leaf nodes is? So what is a leaf node? Okay, so see here, if we talk about this particular node, as you carefully observe, it having a two children. One is this and another is this. Similarly this node having a two children, one is this and one is this. Similarly this node having a two children, one is 6 and one is 7. Clear. So basically if I talk about these 4 nodes, this one and this one, they do not having any children. So basically the nodes which doesn't having any children, which are known as a leaf nodes. Which doesn't having any children, which having a 0 children, are known as a leaf nodes. So this is a leaf node. Clear. So this is a leaf node. This will be our leaf node, this will be our leaf node, this will be our leaf node, and this will be our leaf node. So we can clearly say that in any tree data structure, the nodes which doesn't having any children are the leaf nodes. So I hope you also understand this concept. So it doesn't means that, let us suppose I take this particular one. So if suppose the tree look like this particular, like this one, it also having any node, let's suppose here is a 8. So you cannot say that this 4 is a leaf node. No, it having at most at least one children. So this is not a leaf node. The leaf node is basically a node which doesn't having any children. So which having a 0 children, that node is known as a leaf node. So this is the concept of the leaf node. I hope you understand also this particular thing. So let me erase this and explain the more terminologies. Clear? So the most and very important thing is, whenever we are doing any type of operation on a tree, we will discuss the coding part of all type of operation, insertion of a node in a tree, deletion of a node from a tree. So basically whenever we are performing any type of operation in a tree data structure, we will start from this root node. Clear? We will start traversing from this root node. We will start traversing from this root node. From this root node, we will go through the whole of the tree. Whenever we are doing the different type of a traversals, we will always start from a root node. We doesn't having basically a reference of this particular node. No, we doesn't having a reference of this particular node. We do not having a reference of all the nodes. Basically, we having only the address of a root node. So from the root node, we will start traversing and performing a different type of operation in a tree. So when we are discussing that portion, I will explain how we start from the root node and perform the different type of operation like insertion, deletion, traversal. So wait for those videos and I will explain. Clear? So let's talk about the node structure. So I have explained that a tree is a node based data structure. If you clearly talk about this is a node, sorry. So this is a node, this is a node, this is also a node, this is also a node, this is also a node. So how this node look like? But what is this node basically is? So basically node is a, you can in a simple language, more formally we can say that it is a structure, user defined data type or struct that we use in a C++. So basically it is look like this one. In this case it having a 3 fields. One is a data field, data. Here is a right field and here is a left field. What is the meaning of this? So basically this circular node is represented actually in this way. Clearly, if you carefully observe, this is a data 1. So here we will store our data, and to the left children of this node, the address of the left children of this node will be stored in this left field. Suppose there is another node like this particular one. I am not drawing the same thing. And similarly, suppose there is a right children to this node also. So the address of that particular node will be stored in this field. So we can clearly say that in the left field, we having the address of the left children to the current node. Similarly, in the right field, we having the address to the right children to the current node. And let us suppose there is no children in the left or a right. So what we can say, here will be a null. Here will be a null. If there is a left or a right children with respect to the current node, we can say the address of that left or right children will be stored in the left field or a right field of the current node. But suppose there is a no left children or right children, the children which is not present at the place of that address, we will write a null. Clear? Null. You have to understand, we need to write a null. Clear? We need to write a null at that place. So I hope you understand the concepts. So basically data field is where we store our data. So from this observation we concluded that if any node doesn't having any left children as well as a right children, so here will be a null as well as here will be a null. Clear? So the node which doesn't having any left children and right children having both fields as a null, so that node will be known as a leaf node. This node is known as a leaf node. Leaf node. So this will be a leaf node. So let's quickly talk about another thing. So I'm erasing these old stuff. So basically let's talk about the another steps. So basically we will talk about now label. What is a label? Clear? So let's talk about the label. So basically label is what? If I talk about the labels of this tree, so this will be the first label. This will be the second level of a tree. And this will be the third level of a tree. Clear? So this will be the third level of a tree. I hope you understand these concepts. So basically if I talk about the nodes present at a level 1, only this node is present. If I talk about the nodes present at level 2, so 2 and 3 will be present. If I talk about the nodes present at level 3, so then 4, 5, 6 and 7 will be presented here. So this is the concept of a label. Let us quickly talk about the height of a tree. So let's talk about the height of a tree. So what will be the height of a tree? Let's see. So basically height of a tree, let us suppose, as we know that this is our root node. Clear? This is our root node. So basically the height of a tree is the longest path from root node to the deepest leaf node. But I am saying deepest leaf node. So when I talk about the height of this tree, so what is the deepest leaf node? This is the deepest leaf node. This is also, you can take any of these. Deepest means the longest path. So this is the longest path, 1 and 2. So the height of this tree will be 2. Clear? Let us say the tree is changed to this particular thing. So if I change this tree, like this one, here is a 8. Now what will be the height of a tree? No, you cannot say that the height of a tree is still 2, because the height of a tree is the longest path from the root node to the deepest leaf node, and now the deepest leaf node is this particular one. Note this, and note this also. If you carefully observe, from this 1, 2 and 3 is the height, here 2, here is also 2, here is also 2. So what is the deepest leaf node? This is the 8. So the height of a tree is basically the longest path from the root node to the deepest leaf node. So this is known as the height of a tree. So I hope you understand the basic terminologies regarding to a tree. In the next video we will see how to implement a tree, how to insert a node, and how to define a node structure. So make sure you are subscribed to our channel. So I will meet you next video. Till then, bye bye.